morning, everyone. I'm Alex with Ada Core, and I'm here to talk about exception handling, specifically about handling C++ exceptions, hierarchies in Ada. Thanks, Ada Core, for bringing me here. Thank you for being here. I'm going to start by talking about the exception models and differences between Ada and C++, and then the interoperation features that are available in GNAT between these two languages, both before and after the recent changes that we have made to introduce base class type matching in exception handling on the Ada side, and the availability of runtime C++ runtime type information for Ada to use. Exceptions in Ada have to be declared explicitly, and they form a flat namespace, so there's no hierarchy there. And Ada exceptions don't have associated application data. You can only raise an exception with a string, and that's pretty much all you get. Handlers can handle multiple exception types or names in Ada speak. You can name the exception occurrence. That's X in the slides here. Oh, I don't want that. You cannot have duplicate handlers for the same exception type, exception name, and you can have catch-all clauses, and you can re-raise an exception with the syntax given here. In C++, you're probably familiar with that, you can use any type as an exception. So they carry data and they are not marked specifically for use as exceptions. And they form a hierarchy that corresponds to the type inheritance system. So if you throw an E4, you can catch and handle that as an E3 because E4 is a E3. So the second handler here is unreachable because you'll have caught that as an E3 already, and that's how the last line is how you do catch-all and re-raise. There are interoperation features between the two languages. You can import types from C++. It just declare a type. It has to be limited. That means you can't copy it in Ada. You can only copy it using a copy constructor. So you import a constructor from C++ and use it to build new instances of the object. It may or may not be tagged. That means it has dispatching primitives, or in C++ speak, that means virtual calls, virtual member functions. And you declare that the type follows C++ conventions by importing it from C++ with a pragma. You can have single inheritance in Ada, so you declare that the type E4 is derived from E3 with this sort of syntax, and then you can also specify that it follows the C++ conventions with regards to layout and stuff like that, and then the Ada compiler will do the magic for you. However, data types and exception types are unrelated in Ada. You have to, if you want to use a data type and be able to handle exceptions of that type, you have to declare that also as an exception. So EX3 here is declared as an exception type for exact matches of the type E3 that is declared in C++. The link is given by the type info object associated with that, with the type. The underscore ZTI2E3 is the type info object for class E3 in C++. And so when someone raises an exception of type E3, that's the handler that is going to handle that. You can get to the data object by instantiating the generic function getObject as getE3, and then in the handler you can call the function to get to the E3 object that was raised. Now, as I mentioned before, back then, before the extensions that we made recently, you can only have exact matches for the types. So this will not handle E4 objects, only E3 objects. And the other problem here is that the getObject function, generic function, does not accept limited types. So this instantiation will actually not work. It can be used for simpler types. It can be used for like integers or access objects that are pointers in Ada, but not for objects imported from C++. And this is a problem if you want to catch actual C++ data objects. So what you can do now that some of the recent extensions enable you to handle an exception and use the getObject address function. It's not a generic, it's a direct function. And with that, you get an access, or you get the address of the object inside the exception temporary storage. And then you don't need copy, so the fact that it's limited type is not a problem. But we can do better now. We can catch hierarchies. So you can declare an exception, in this case EB3, and you annotate the type info object with tick class, and that's syntax in Ada to mean this type or derived types from that. You can also use a higher level generic function, getAccessToTaggedObject, to get an access, to get access to the object in the exception without going through all that syntax that I showed before. So this one will actually catch E4 objects, the derived, and you'll get a reference to the E3 part of them. And there was another limitation that we have overcome with the recent extensions, which was that you could catch any exception, any kind of exception with the catch-all, and then you could test that it was a foreign exception. You could test that it came from C++, but you couldn't tell which type that object had. So it was risky to use to access those objects there, because you had to somehow, by other means, know what type they had. And there's no dynamic checking. That is not possible because the types and the exceptions are not related. Neither the compiler nor the runtime can verify that you're actually getting something consistent there. So now you can test the type. You can use type info. GetTypeInfo is a new function in the interface for exceptions. And you get you get a pointer to a C++ type info object, and the API of that class is available now in Ada. So you can test the name as a string and see, oh, this is the type that I'm looking for, and then you get an access to the object if you wish. So the fact that data types and exceptions are unrelated still makes room for some safety concerns, because again, neither the compiler nor the runtime can verify that you're doing the right thing, that you are accessing the object with its type. We don't have a solution for that. It's still an open problem. It's there, but if you get the object with the type corresponding to the exception that you're handling, then you will be safe. The other limitation is that we have only one-way compatibility. There is actually, you can handle exceptions from C++ in Ada, and there is a generic function that can raise a C++ object exception from Ada that C++ can handle. However, this function is also, sorry about that. Thanks, Olivier, for the laptop, by the way. No, I think we're almost done here. So there is this one function, but it has the same limitation, so to speak. It does not accept limited types. So if you want to raise something like a type imported from C++ that must be limited, then you're out of luck. We are trying to figure out how to overcome that limitation now. So a summary of the extensions that we have made recently. You can get access to the objects in the exceptions in place without copying, so the fact that they're limited does not play a significant role. We had a problem of re-raising C++ exceptions, and the exception object would be considered handled and released too soon. We have fixed that. We have introduced syntax to specify base type matching, so you can handle exceptions that will catch derived types as well. And this was implemented in the runtime as a new foreign exception kind. We had to extend the language in a subtle way, because sometimes, in Ada you cannot have handlers for the same block. You cannot have more than one handler for the same exception type. But when it's a flat namespace, that's easy to tell. When you can handle derived types that you don't even know that are derived types, then the compiler can't even check that there are two handlers that can handle the same type, because it doesn't have access to the type hierarchy. So we have to allow that and specify that the first matching handler is the one that gets the exception. The type info objects are now exposed in Ada, so you can do interesting stuff, including dynamic casting. And we can get the full objects for catch-all handlers, which you could do before with limitations. Now those limitations are overcome. And that was it. Questions? Yes, we have questions.
I'd like you to do a little design work for me right on your feet. If I wanted to do this in COBOL, what would I need to do?
Gee, I don't know a lot of COBOL.
Well,
myself.
that's not necessary, but like, what of the work you've done, for example, could I take advantage of?
I doubt it. It was all sort of very specific to the Ada compiler and runtime. You can probably draw inspiration from that.
Already?
But the features are, the exception features are really part of libgcc. So it's just a matter of figuring out how to use them and plug them into your compiler and runtime.
Are Ada objects compatible with C++ objects? Interoperable?
When you use the import feature that specifies that they follow C++ conventions, yes. If you don't, then you have to know what you're doing to get the same, to get compatible layout.
So, two questions. First, what motivates this work? What kind of workload are targeting to extend the language and all this new feature? And do you plan to add some tool like FFI to simplify you can specify a library and the tool like get all this information and create some Ada wrappers? So do not need to deal all this C++ internal, because it seems a lot of work to track down which objects, the mangling name, and how to import this, and this is a lot of boilerplate and subject with a lot of issues.
So yeah, so the motivation is that presumably there are customers interested in combining programs with parts in C++ and parts in Ada. And well, without these features, this would be just pretty much impossible. Now, well, not the exception features specifically, but all the interoperation that has been a significant feature with lots of requests. So there is interest in this sort of interoperation. As for generating the compatibility layers, there is an option in GCC that you can use that will take, I'm not sure that it has to be preprocessed. You can probably just take a C++ source file, and it will identify the types there and the global variables and global functions, and will generate corresponding declarations in Ada. So it's with the imports. So it's magic. It's very beautiful what it does. I don't think it handles exceptions, because that's not declared in the C++ side. So that would be something interesting to explore, I think. But the option, if I remember correctly, is -f dump Ada spec with dashes separating the words. Does that ring a bell? Yeah.
It's unfortunately very limited for C++. Yes, there are lots of limitations with respect to.
Yeah.
That was devised for C initially to allow to generate Ada bindings for C libraries from their headers, and then we sort of extended its feature for C++, but we didn't go very far there. So there are certainly lots of limitations.
What I have seen was pretty complete.
Okay,
So
well, nice, but I mean that's a byproduct of what we did for C essentially. Probably some attempts for very specific parts of C++, but it's known not to be extensive for C++. But if it worked well, at least on the subset you saw, that's that's good. I doubt it handles exception indeed. I agree.
No, it doesn't. So you still have to figure out the type info name and put that in. and it insists that we log in. Is this Windows? All right, more questions? Then I will plug in a personal note here. Next week, the FSF turns 40. We're looking forward to the celebration, and I hope you will support the FSF if you can. Thank you so much.